I'll be going over question 8 from sample final number 3. So we are asked which of the following statements are false. So let's look at each letter choice. Letter choice A. If we know that probability of A is 0.6 and probability of B is 0.5, then A and B cannot be mutually exclusive. Let's verify this by finding the union. So if A and B are mutually exclusive, that means that they can't happen at the same time. So the probability of A and B happening is equal to 0. It's much easier for me to visualize this on a Venn diagram. So if it's mutually exclusive, it will be like this. There's no overlap between the two events. So if we want to find the complement of A or B, so A or B complement will be 1 minus P A or B. So if we assume that they're mutually exclusive, then we will have 1 minus 1.1, which will be negative 0.1. So remember from probability that we cannot have negative probability for events. So in this case, A and B cannot be mutually exclusive. So A and B has to be greater than or equal to 0.1 in order for us to not have a negative probability. So let's look at letter choice B. If A and B are independent, then the product of B and A will be 0.24. Let's verify this. So PA times PB will be 0.6 times 0.4, which indeed equals 0.24. So this is true. They are independent. Look at letter choice C. If we're given the union between A or B and their individual probabilities, then A and B has to be independent if the following numbers are true. So let's verify it. P, A, and B. So if I take 72% minus 90%, it'll give me negative probability A and B. So negative 0.18 is equal to negative P, A, and B. P, A, and B is equal to 0.18. So let's see whether or not 0.3 multiplied by 0.6 equals 0.18. So 6 times 3 is equal to 18. If we just have one decimal point, it will be 0.18. So this is indeed true. Let's look at letter choice D. If A and B are mutually exclusive, and if A and C are mutually exclusive, then B and C must be mutually exclusive. This statement is false because we can have a situation like this. So we can have a situation like this. So this is our sample space. So we can have A right here. So A and C are mutually exclusive, right? So they don't overlap. And A and B are mutually exclusive, but they don't overlap. But B and C can overlap since there's probability here. So since P, B, and C greater than 0, it is not mutually it can be non-mutually exclusive. So this is false, which leads us to letter choice D. Now let's look at letter choice E to make sure it's the only false statement. So two events that are mutually exclusive cannot be independent. Now this is true because if we assume probability of A and probability of B to be greater than 0, if we know that if they're mutually exclusive, so if their intersections is equal to 0, then we know that PA will be some number and PB will be equal to 0 or vice versa. So if events are dependent, that means that knowing one event will alter the probability of the other event. So if I know that they're mutually exclusive, then that means if I know that probability A is going to be some number, then probability B has to be equal to 0 in order for the mutually exclusive condition to be satisfied. So the letter choice here should be D.